Today we have a very short note sheet. It's only 3 problems, but conceptually this can be a little bit more challenging. Today we're going to be solving log equations. The difference from what we did with exponential is that all of these problems start with a log in their equation. So in order to solve log equations, there's 2 methods we're going to be using. The first method involves setting the arguments of each log equal to each other. This can only work when you have one log on each side. You're going to set those arguments equal to each other and solve, but you have to be careful you check for solutions that do not work. So we're going to talk about how the argument, I'm going to have you guys write a little note down here. The argument always has to be greater than 0. It cannot equal 0 as well. So it has to be greater than 0. The second type of problems we're going to be solving involve the circle of life. And that's when you just have one log and then there's a number on the other side. We can use this circle of life. Now, in order to get the problems to look like this, sometimes we will have to use the properties of logs. And I'll show you those examples in just a moment. So let's start with the first problem. The first problem, we have logs on both sides. So it looks like we're going to be using this first method here, but in order to use the first method, we need one log on each side. So I am going to condense these 2 logs using the properties of logs. Leave the right-hand side alone, or I'm sorry, left-hand side. Still trying to figure out my left from my right. And on the right-hand side, now I got it, we're going to use the properties of logs. Since there is a minus sign, we're going to make the quotient of what is on the right-hand side. Remember taking that x minus 1, putting it on the top, and the x plus 1, and putting it on the bottom, or in the denominator, if you will. Now from here, because we have a log on each side, we can now set these arguments equal to each other. So what we're going to do is we are going to say x plus 5 equals x minus 1 over x plus 1. Again, we can do this because it's just like having the same base with exponential functions. If you have a log here and a log here and they're equal, the arguments have to be equal as well. Now, to solve this, let's think about cross products. I can take x plus 5, multiply that by x plus 1, and that's going to equal the product of 1 times x minus 1. When we multiply on the left-hand side, you can either do a box, or you can FOIL. You should get the x squared, 5x, 1x, and 5. And then on the right-hand side, getting the x minus 1. And then let's bring everything to one side. So we'll subtract the x, add the 1. And then we can factor to find our solutions. Now, you need to be, oh, where'd my negative go? You need to be extremely careful in this unit because you will see that you get solutions here, but these solutions may or may not make the argument of the logs negative or equal to 0. Always go back to the original problem, and what you're going to do is test each of these numbers. If I sub in a negative 3 for x, notice that that would make this a positive 2. We're good. But if I sub in a negative 3 here, unfortunately, the entire argument of the log would be negative 4, and that's no good. If it breaks any one of these arguments and makes it negative or 0, it will not work for the entire problem. So we need to say goodbye, to that answer. Same thing with negative 2. Notice negative 2 works here, but again, does not work here. So as a result, this problem actually has no solution. So be on the lookout for these solutions that do not work in the problem. And in this case, we start off right away with one that does not work. Going to the next problem, notice that we just have one log. That means we're going to be using the second method where we isolate the log and then do the circle of life. So with that being said, I need to subtract the 3 to isolate the log, and then I need to divide by the 4. You cannot do the circle of life if there's a number in the front. You need to isolate the log completely first. Oh, doing that a lot. Now, from here, we can do the circle of life. Remember that there's a base of e, and if I do the circle of life, note that I'm not saying the argument is negative. I'm saying e to the negative second power equals x, which is okay. What we can do then is we can go to our calculator and we can find that, and you'll see this is not the natural log of -2. This is e to the negative second power, which again, we are okay with. Remember, the domain of that function e is all real numbers. So we can go to second, it's e button. Oh, come on. Second e to the x, and then go to -2, and we're getting an answer of approximately 0.135. Now, of course, still check this, but notice that if I sub that in for the argument right here, 0.135, it does not make it negative, nor does it make it equal to 0. I'm actually okay. I mean, you can even go further and actually type this in, and you can type in that answer we just got, and then add 3 to it, and you'll see that we do get that -5 that we are expecting to get on the other side. So, final problem for today, and then you guys will get an opportunity to practice, is a problem right here where, again, we have 2 logs on one side equaling a number. Now, that means that because they're on the same side, we're going to use this method right here again, where we want 1 log equal to a number. So we are going to condense these 2 logs using the properties. Now note there is a plus sign between the logs, so that means that when I condense into 1 log, I have to multiply the x with the x minus 7. Now that's going to give me x squared minus 7x. Be careful. So many people forget that x. You got to make sure you distribute the x to each term. It is a very common mistake. I'd say about 50% of people make that mistake at some point. Now, the other big mistake is that people forget there is not a log on the other side. You cannot say x squared minus 7x equals 3. You have to do the circle of life here. So we're going to say 2 to the 3rd power equals x squared minus 7x. And then from there we get 8. And then from there we can factor this. And get 2 solutions again. Now, once you get those solutions right away, go back up to the original and check to see if they work. Starting with the first log, if I sub in an 8 here, I'm good. If I sub in an 8 here, I'm good. Notice that in both cases the log stays positive. Moreover, I can evaluate 2 to the what power equals 8, that's 3. 2 to the what power equals 1, well that's 0, and I can easily check just doing mental math there. Now, 8 is good, but is -1, right away. I mean, I don't even have to go to the second log. Already it makes that argument negative. No good. So that is your final solution. Please email me with any questions, but if not, I have a circuit that I would like for you to complete and submit through Schoology once you're finished.